Welcome back. Hope you have gone through the part 1 presentation on syllogisms. If not, please go through that before you move further, because this presentation is designed as a continuation to part 1 and we keep referring to the concepts discussed there. If you are here after going through part 1, then let us move further. In the earlier presentation, we discussed the question Q1 in great detail. There we felt that such an elaborate way of doing syllogisms is not appropriate for aptitude tests because of the time constraints. In this presentation, we shall see how to do questions faster using the diagrammatic method itself. The trick is to work with just one diagram to represent a premise and imagine all other possibilities in the canvas of our mind. Let us learn to do that. As we had learned earlier, there are 4 standard types of relationships between two categories. They are universal affirmative, particular affirmative, universal negative, and particular negative, which in turn give rise to 8 standard relationships when you interchange the position of the two sets involved. Let us take a relook at the diagrammatic representations of the standard relationships. Universal affirmative. Example: all eagles are vultures. The two possible diagrams representing the premise are shown on the left-hand side of the slide. If we are to use just one diagram to represent this premise, then we shall draw it as shown in the right side of the slide, with eagles completely within vultures. However, when we do that, we should keep in mind that the set of eagles can grow bigger and bigger and grow as big as the set of vultures. But eagles cannot come outside vultures. That is the most important thing that you should keep in mind here. Now look at particular affirmative statement. Example: some Chinese are Russians. The various possible diagrams that depict this premise are shown in the slide. In an aptitude test situation, we shall draw just the diagram shown on the right side of the slide to represent the relationship, and while doing that, keep in mind that this is just one of the 4 distinct possibilities shown on the left. You should remember that Chinese can go completely inside Russians, or Russians can go completely within Chinese, or Russians and Chinese can completely overlap to represent the same set of elements. But they cannot be disjoint. In all the diagrams, there is an overlap. So the most important thing when you represent a particular affirmative premise is that there should be an overlap between the two sets. Universal negative. Example: no table is a chair. Here, there is only one possible diagram. The set of tables and the set of chairs should not touch each other. It should be 2 separate circles. There should not be any common element between the two. Now consider a particular negative statement like some eggs are not jugs. The possible diagrammatic representations of this relationship are given on the left side of the slide. Here, the most important thing is that there should be some portion of eggs outside jugs. That is, there should be at least one element of the set X which is outside the set jugs. So we shall use a diagram as shown in the right to represent a particular negative premise. There may be an overlap, maybe not, but definitely at least one of the elements of X should be outside jugs. When you draw the diagram, draw the set jugs as a circle and represent X outside as 1 or 2 X marks. Let us apply this learning to do some syllogism questions. Refer question Q2. In aptitude tests, syllogism questions come in a variety of forms. This is one of those types. Here, we are given two premises and a set of conclusions. We need to pick the conclusion or conclusions that follow from the given premises. Let us apply the diagrammatic method that we learned just now to find the answer. First, let us draw a diagram each to represent the two given premises. In the diagram representing all radios are TVs, even when we draw the radios completely within TVs, we should keep in mind that this is just one of the possibilities. The set of radios can grow bigger and be as big as TVs, but it cannot move outside TVs. In the case of no TV is a stereo, there is only one diagram possible. There will not be any overlap between TV and stereo in this case. Now that we have drawn the diagrams representing the individual premises, there comes the all-important step of combining the two diagrams. Here, we keep the diagrams as they are, and the combination diagrams are imagined in the mind. Since radios should stay within TVs and TV should not touch stereo, we can see that radios and stereos will not touch each other. So we can see that among the two given conclusions, the first one, no radio is a stereo, is a valid relation. The second one, all radios are stereos, will not be valid as there cannot be an overlap between the two. So the answer is conclusion 1. No radio is a stereo. Now refer question Q3. What you have to do in this question is similar to what you did in Q2. First, draw a diagram each to represent the individual premises. We should remember that even though we restrict our figures to one diagram per premise, they are not the only ones that represent the premises. Thus, in the case of the first premise, some A's are B's, A can be completely within B, or B can be completely within A, or A and B can represent the same set of elements. That is, they can completely overlap. What should essentially be there in all the diagrams that represent some A's are B's is an overlap between A and B. Likewise, in the case of some C's are not B's, the essential thing that should happen is that at least one element of C should be outside B. With that constraint, C can overlap with B either partially or completely, or be disjoint and remain completely separated from B. Before you combine the two diagrams, it would be good if you recollect the learning we had from question Q1 in part 1 discussion. There, we learned that a relationship that may be true in a certain combination diagram need not be true in another. In order to say that a relationship between two sets is valid, it should be valid in all the possible diagrams. If a relation between two sets is invalid, even in one of the possible combination diagrams, then we should say that this is not a valid relation. Let us go ahead and combine the two premise diagrams in question Q3 and see which all among the four given conclusions are valid. What we shall do is to move the premise diagrams around, keeping the constraints in mind, and check the validity of each of the given conclusions as we move them around. What are the constraints here? Since the first premise is some A's are B's, there should be an overlap between A and B in all the diagrams. Since the second premise is some C's are not B's, there should be at least one C outside B. Within these constraints, we can move the diagrams around as per our whims and fancies. Actually, you should not be drawing any of the combination diagrams. You need only the basic premise diagrams. The combinations should be imagined in your mind. We have shown a few combination diagrams in the slide for explanation's sake, for your better grasp. These are only a few of the possible combinations. In all those diagrams, there is an overlap between A and B, and there is at least one C outside B. You should be able to imagine these kind of scenarios in your mind based on the base premise diagrams. Now let us concentrate on conclusion 1. No A is C. Is that valid? Remember, a particular conclusion will be valid only if it is valid in all the possible scenarios. Look at the diagram given in the slide. No A is C is true in figures P and R. But it is not true in figures Q and S because in those diagrams A and C are overlapping. So conclusion 1 is ruled out. Now look at conclusion 2. Some A's are C's. It will be true in figures Q and S, but not in P and R. So that is also out. What about conclusion 3? Some A's are not C's. It is valid in figures P, Q and R, but not in S, where A is completely within C. So that is also ruled out. Now conclusion 4. All A's are B's. Here, there is no need of looking at premise 2 itself because the given conclusion is between A and B. This relation's validity can be checked by looking at premise 1 alone, which relates A and B. That premise says some A's are B's. From that, we cannot conclude all A's are B's. From the diagrams also, we can see that it is invalid in all the figures except figure S. So we see that none of the conclusions given in the question is valid. Let us look at one last question before we stop. Refer question Q4. In the question, there are 3 premises between 4 terms. As there are 4 terms or categories to play with in this question, it is a bit more complex to analyze than the earlier ones. Let us begin by drawing the individual premise diagrams. The individual premise diagrams are given in the slide. Figure 1 represents the first premise, some big B or small b. The most important thing in this diagram is that there should be an overlap between big B and small b. Figure 2 represents no small b is chota b. Here the critical aspect is that there should not be any overlap between small b and chota b. The third premise, all bada B or chota b, is represented in figure 3. There, bada B cannot go outside chota b. Now let us combine the diagrams and check the validity of the given conclusions. All the conclusions given are between big B and bada B. In the diagrams, big B is given in blue color and bada B in yellow. In order to get a relationship between big B and bada B, we need to combine all the figures, figure 1, 2 and 3 simultaneously. Once again, be aware of the constraints before you play around with the diagrams. The constraints are 1. Big B and small b should have an overlap for sure because some big B are small b. 2. Small b and chota b will not touch each other because no small b is chota b. 3. Bada B can move around and expand or contract within the space of chota b only. When you imagine the different scenarios in your mind, remember the two important points once again. A particular conclusion will be invalid even if it is invalid in one of the possible situations. And a particular conclusion will be valid only if it is valid in all the possible scenarios. Let us go through each of the given conclusions one by one. Conclusion A. Some Bada B are not Big B. See the figure given in the slide. There, all our required conditions are met. Big B and small b are having an overlap as per some big B are small b. Small b and chota b are not touching each other because no small b is chota b. Bada B is within chota b as all Bada B are chota b. Is the statement some Bada B are not big B true here? No, it is not. In the diagram, Bada B is completely within big B. So all Bada B are big B. So there is no Bada B which is outside big B, and hence the conclusion some Bada B are not big B is not valid. Keep in mind that there may be arrangements where some Bada B are not big B. But that will not be true always, as in this case, and hence not a valid conclusion. Let us try conclusion B. All big B are Bada B. Take the same diagram that we considered in the previous case. See whether the statement all big B are Bada B is true there. If that is to be true, big B should be completely within Bada B, which is not the case here. It is not true in this diagram, and so that cannot be a valid conclusion. What about conclusion C? Some big B are not Bada B. I should warn you that it may get a bit confusing in this slide. So listen carefully. As per the premises, big B and small b should have an overlap, however small, for sure, because some big B are small b. Further, small b and chota b will not touch each other because no small b is chota b. So in whatever way you rearrange the diagrams, chota b cannot overlap with that part of big B which is in overlap with small b. That area is represented by the slanted lines and indicated by the arrow in the diagram. As per the third premise, all Bada B are chota b. So Bada B can move around and expand or contract within the space of chota b. But it cannot move outside chota b. Now, as there is a part of big B with which chota b cannot overlap, Bada B also cannot overlap with that part. So, there is going to be at least some part of big B that does not overlap with Bada B. And that means some big B are not Bada B. Now this condition is going to be true in whatever way you rearrange or combine the diagrams. And so, conclusion C is definitely valid. If you were not able to comprehend the thought process clearly, listen to this slide once again. Now we have one more conclusion to check out. Look at conclusion D. Some big B are Bada B. For this to happen, there should be an overlap between big B and Bada B. But that need not happen always, as can be seen from the figure given in the slide. Here, there is an overlap between big B and small b as required by premise 1. No small b is chota b as per premise 2, so they cannot overlap. In this case, big B and chota b are also not overlapping. As bada B is within chota b, it does not touch big B, and so the statement some big B or bada B is not correct here. Hence, it is not a valid conclusion. So we conclude that option C is the correct answer. Once you get the hang of the approach, you will be able to do these kind of questions faster. Now, as we come to the end of this discussion, it would be good to take a recap of the things that we learned from the two presentations on syllogisms. First, we understood what is meant by categorical syllogism, and then went on to learn the various standard ways in which two sets can be related. We looked at the classification of relationships into four categories, namely universal affirmative, particular affirmative, universal negative, and particular negative, based on the qualifiers used, and then understood the typical characteristics of their diagrammatic representations. We saw how to combine the diagrammatic representations to validate and identify the relationships between non-related sets. Doing syllogism questions requires a certain bend of mind. If you are not able to grasp the idea in one listening, please go back and listen to the presentation once again. Thank you.